possibly study with me that isn't live? Who would watch something like this? This is what weird content, man. Like the whole point is study with me is you can study with them, but like if you make it a video, it's just normal. So how about that, right? So instead, this is gonna be a combination. Study with me live, hashtag slash backslash w dot exam one for statics. So we're gonna do 50-10, I think, but it's gonna be focused on explaining and talking through the first exam for your engineering statics course. So with that, let's get into. Oh my goodness, phone shut up! I say phone shut up, it is my friend I'm talking to. He's got a lot of games. He's a gamer. He's trying to play them. So let's study session number 1 now. Let me move this over. There. Perfect. And how about that go? Wait, why the heck is study cam still here? Get out of here, study cam. Gosh, dang. Jeez. So, yeah. Convert each of the following. So, hopefully these don't take too long. We can do A. We're starting out with 175. What is this? Pound over feet cubed. And it's going to eventually have to turn into kilometer meters cubed. Oh, kilonewton. Okay, so how do we get right here? Pound is that many newtons. So we just have to know that's going to be. So we're going to put pound on the bottom. And we're going to put kilonewton on the top. This is going to be 4.448 times, I think 10 to the negative third or 10 to the positive third. What is, if I go into app, science tools, and then I do unit converter, and I do SI prefixes from base to kilo, from base to kilo is times 10 to the negative third. So that should be right. And that is equal to 1 pound. Okay, so now we should have it in kilonewtons on top. And I have to get feet cubed to the meters per second cubed. So this should be now, let's put FT3 on top and then M3 on the bottom. And this is going to be 1 meter. This should be 3.2808. And now here's the thing. Is this cubed as well? I think that is also cubed. Yeah, so with this now, this gets crossed out, and then this gets crossed out, leaving our answer to be, let's see here, 175 times 4.448 times 10 to the negative third times 3.2808 times 10 to the third. And I'm getting what? Hold on. This should be kilonewton. What did I type in wrong? 175 let's see. 175, 4.448, 3.288. To the third. Yeah, okay. What's the difference here? If I do 175 times 4.448 times 10 to the negative third. 3. Let me put parentheses times the cube. Ah, yes, that's what I forgot right there. So this should be 3.2808 cubed, not e to the third. Yeah, that's the only difference. So now I'm getting 27.5, and the thing here is going to be kilonewtons meters cubed. Okay, sweet. That's part A. Part B is we've got 6 feet per hour, and we need this in millimeters per second. So there's 3,600 seconds. Wait, seconds have to be on the bottom. So this is going to be 1 hour is 3,600 seconds. So now hour cancels out. We have the seconds, and now we have to do feet to millimeter. So up here we should have millimeter on top, and that's how many of the FTs. That is 3.2808 times 10 to the negative third FT. Okay, this should work out. So hours cancel, FT cancel, and we're left with, this is going to be in millimeters per second. Let's do the math. It's going to be 6 divided by 3,600. Then this is going to be divided by 3.2808 times 10 to the negative third. And here I'm getting 0.508 meters per second. And then lastly, here we have 835 pound-foot, and that's that. We have to convert this to kilonewton meter. So we're gonna have this on the bottom and meter on top, and we're given that 1 meter is 3.2808. So that should work out. And now pound a kilonewton, which we already have here, is going to be 1 pound is 4.448 times 10 to the negative third kilonewton, and FT cancels and LB cancels. So our ending unit should be a kilonewton meter. And now let's do 835 divided by 3.2808, and let's multiply that by 4.448 times 10 to the negative third and I have 1.132 kilonewton. So these are all right. So that's the first question in the exam. Let's move on to the next one. So here, it's the plate is subjected to two forces at A and B as shown. And they say that theta equals 60, and that's right here, so this is going to be equal to 60. Using the triangle method. Okay, so they asked for a very specific method here. They want the magnitude of the resultant between these two, and its direction measured clockwise from the horizontal. Okay, let's identify which one's larger. 8 kilonewtons is larger, so this is going to help us a little bit, since larger means that this would, in theory, be the longer of the two. We can kind of draw the triangle a little bit guessy, a little bit calculated from here. So we're gonna have A coming up like this, B coming down, but not quite as high as this. And since we know that this forms a 90-degree angle and that this was 60, we can find that this angle here is 90 minus 60, which is 30. We've got an angle here of 30 degrees. Opposite interior, this is 30. And we can do the same thing here, 90 minus 40, making this angle here on the inside 50 degrees. So we know that the opposite interior angle here is going to be 50. And we know that these three angles add up to 180. So angle R is going to be equal to 180 minus 30 minus 50, which equals 100 degrees. And then this here, let's see, we have this R. This is the resultant. And if you look, there is another angle there. The resultant is above. And that's the angle they're asking for in part 2. But let's not get ahead of ourselves. From here, we use the law of cosines. And let me quickly pull that up on my secondary computer. Oh, my computer shut off. That's too bad. I can find it quickly here too. Yes. The law of cosines here says that R is going to be equal to the large square root here of F A, I think squared, plus F B squared minus 2 F A F B cosine theta. So then R is going to be equal to 8 squared plus 6 squared minus 2, 8, 6 cosine 100, which equals, let's see, I'm getting 10.8 kilonewton. And now to find this angle, well, maybe not that angle. I wonder what angle they're trying to find. we know this whole angle is 30, so they're trying to find this smaller angle. So we know the whole thing is 30. I'm going to have an outside angle, and then, of course. So now from this, we use the law of sines, and that is to get this angle from here, from vector A to vector R, which this is going to be R over the sine of little r is going to be equal to FB sine of, I don't know what to call this. The symbol that I made up, the fish, goldfish. Yeah. So that is going to be 10.8 over sine of 100 equals FB is 6. And we use this because law of triangles says something about this force pointing this way. That's where we get FB's equal to that from. Pardon me? Tis well. Okay. Do apologize for that. 6 over sine of this unknown. So now we cross multiply, which means that 6 sine 100 equals 10.8 sine of this. So now we divide both sides by 10.8, and then we say that the inverse of this angle is going to be equal to 6 sine 100 over 10.8, meaning that this angle is going to be equal to we're getting 33.16. Okay. Now, we know that this is R here. This is FA. We know this angle is 30 degrees. Now we know this angle. Oh, something doesn't really add up here. Well, it looks like it's going to be below. It looks actually like... Let's draw it this way then. The way this is looking like it's going to turn out is instead... R is actually below. This is the x-axis. This is FA. We know this angle here is 30 degrees. And we know that this angle, I'll probably draw it here, is 33.16 degrees. Then what's this angle here? Well, that would be 33.16 6 minus 30, which is 3.16. I think it might be like 3.17. Yeah. 3.169, so 3.17. With this known, now we have that our angle, which I'm going to call this, I was never good at drawing these fish, equals 3.17, and that the magnitude R is 10.8 kilonewtons. Okay, on to the next one. The screw eye diagram. Okay, this one's neat. This one's interesting. Is subjected to two forces. Find the x, y, and z components of the force vectors F1 and F2. And the bonus is find the direction angles theta x, theta y, and theta z. 3 points extra credit. So from here, we can just list that right there. F1 equals 300 newtons. Theta 2 is, I think that would be theta z. Here. Is going to be equal to 30 degrees. Which means that F1z is equal to 300 cosine of 30, which equals 259.8 newtons. And we can do this for y, and we do this for x as well. F1y is going to be equal to 300 sine of 30. Which is equal to 150 newtons. My apologies. This would actually be, I have to pull this table up in front of me, so I have to stop looking over. Let me log into my secondary computer. Okay, it should be coming up real quick. Yeah, okay. Yes, so fx is actually f sine theta y cosine phi. They call this theta z. Now, the only reason this is theta z is that the z-axis is here, the y-axis is here, and this is the x-axis. So they messed our axes around. This is something you'll find a lot in physics exams, is they will throw x, y, and z off. Your formula sheet will tell you that it's theta y. So if you don't know the background information, right? If you don't know the proper technique, that it's taken from the top axis, when you're measuring this, you would take it from the horizontal axis instead, because it says that one is theta y. I think that's why they do it. I think it's really silly. So this would be cosine of phi, which phi is this angle here from what should be the x-axis, so this should be 45. Which I'm getting to be 106. I'm just going to call that 106 newtons flat. This actually rounds it to 106.1. And then we want F1Z, which mine has this as 300 sine of theta z sine of phi. So sine of 45. It should be the same thing then, 106.1 newtons. So that's force 1. Let's do the same thing for force 2. So force 2x, or force 2z. Let's see. It looks like I wrote ZZ. This is going to be, let's see, force 2 is 500 newtons. It's going to be 500 cosine of... What? Looks like 120. Which I'm getting to be negative 250. And then we have F2y. 500 sine of 120 cosine of... Looks like that's also 45. And this is going to be equal to 306.2. And let's do ZYZ. Sorry. This should be X. And F2ZYX. This should be 500 sine 120 what was double sine? Sine of 45. My mistake. F2Z is double sine, F2X is sine and cosine. This only worked. Oh, my mistake, my mistake. This should be cosine, this one should be double sine. F2Y. No. F2Y should be this. f2z. X, Y, and Z are all flipped. This is why they do it. This is why they do it, and it's so stupid. So taking it from the top one should be for... That one should be for Fy. Our Fy is Fz. So that's fine. And then we take it x is where z is. So then we want x Fy, we do x. X is sine theta cosine. So this one should be cosine of 45 and 500 sine 120. See, for x, that would be where z is, and z is usually, this one is usually double sine. But perhaps now we have this angle here, which we know is 60. So would this then here be cosine 60? And this is all in newtons. Okay. Oops, I forgot to fix this one. Since this one is, see, Fy. This one should just be cosine 45 then, shouldn't it? Okay. Okay, yeah. We're given, for the first one, angles to the plane. For the first force, but for the second force vector, we're given angles to the vector itself. It looks, and would that be the difference? My notes correlate to this, but these are also correct here. Different methodology, very interesting. I'll star this problem. It would be definitely worth discussing with my teacher further, because it is different. They are laid out different. Like we have 45 going to the axis of this. We have 60 coming from here to here, so we just take the inverse, or not inverse, we just take 90 minus that. We get this negative space. That's 45, and this is because we're not given anything from the z-axis. So we have, this one's directly given, and the other two have to be interpreted, or interpolated. I'm thinking that's the difference. Okay, and then the bonus. I think I did get the bonus for this one. I did the test. We're going to have theta x, theta y, and theta z. These are definitely worth putting on the note sheet is it's going to be cosine inverse and cosine inverse. Can be a bunch of cosine inverses. This one's going to be f1x over f1 for x. Yeah, so they just want it for force 1. And force 1 is going to be 300s. These are, I think, all going to be over 300. And then it's going to be 200 and, oh, this is for x. Got to be careful. 106.1. This one is for y, so this one's also 106.1. And this one's for z, so this is 259.8. Except for this. Angle theta z, we have to watch out. We got it here. We listed it already, so theta z equals theta z. Which is going to be 30 degrees. We found that already. Here are the ones we need to find. Here I'm getting 69.28 or rounded 69.3, and that should be oh, my mistake. That's negative. And then this is 110.7 rounded 110.8. Gotta check, was that really negative this whole time? I got it as positive. Because this is negative right here. Definitely, this is definitely worth going over. My understanding of this is probably about a 60%. So, not great. But we can tackle this. These are always fun. And let's see. Yep, this is what you have to watch out for. We have a z-axis on top, y-axis on the side, and an x-axis where it's all flipped. It's all flipped. It's so unnecessary. It's unnecessary. So, we can start by listing the points. That's why I like these. You don't gotta think. You just gotta do it. Looks like we have points A, B, C, and D. A is going to be 0, 6, and 0. B is going to be 3, 0, 2. C is going to be 2, 0, negative 1.5. And D is going to be negative 6, 0, negative 3. Now you'd think this would be x, y, z, but what this is really is y, z x. And with this, we can find vector AB we can find vector AC, and we can find vector AD. Vector AD is going to be -6, -6, -3. AC is going to be 2, -6, -1.5. And AB is going to be 3, -6, 2. And we also want the magnitude of AB, the magnitude of AC, and the magnitude of AD, which is just going to be the square root of everything squared. So we're going to have 3 squared plus 6 squared plus 2 squared, all square root, which is going to be 7. And then here we're going to have the square root of 2 squared plus 6 squared plus 1.5 squared, which is going to be 6.5. Here we're going to have the square root of 6 squared plus 6 squared plus 3 squared, which is going to be 9. So from here now we can get the lambda for AB, lambda for AC, and then the lambda for AD, which these are just going to equal apologies again. Okay. So this is going to be I hat, J hat, and K hat. For a free body diagram, we're going to have, looks like tension here, and tension there, which we can call TAD, TAB, and then TAC. And then, of course, we have force F. All these acting on this point here. Okay. With this, these are all going to end in a 7. These are all going to have a 6.5. And at the top, we're going to have 3, -6, and 2, 2, -6, -1.5, and we're going to have a -6, a -6, and a -3. Now here, you might ask, well, let's see. Okay. Hold on. Let me try something because I'm getting something very slightly different. It's disturbing me. Whoa, boy. Let me try something else too. I think that's that one's simplification. The top one though. That might also be simplification because yeah. Okay. Okay, you know it's the same thing. It's the same thing. These are all right. Except now yeah, okay, this looks good. I think this is fine. But with 22 seconds left, we can say that we just put T AB here, T AC here, and then T A D here. That almost looks the same. So let me just really make that a B. And now this gets carried over to all of these. So break real quick. Oh my gosh, there's me. Hello. I like how you can almost just barely see my head. There's got to be a better place for that camera. Got to be a better place. But like my monitor is ow is right there. Really elbowed myself right there. Oof. So like I can't tilt it any more down because then you'll just be seeing the top of my monitor. You have all this space up here. My chair might go up more. In fact, I hope it does. Oh, look at that. This is actually bad because now I'm looking like way down on my monitor. There's got to be a little in between. Hold on. How's this? It's a good in between. I think my chair accidentally sank all the way down. I got a drumming stool over there. That would be probably terrible for posture. take it easy. This is not real brain rot, this is a bird video. They just put a horrible sound effect over it. I don't know if the bird was questioning too much. I think it was just observing its surroundings. It had a very jerky motion. Yeah, I got this computer out of the caves and the dungeons where it crawled out of. This poor Chromebook. I hope it knows how much it's hated. I need to listen to some insane clown posse. That's what I need. Oh, sweet. Most viewed Overwatch clips of the week. That's gonna go on this big monitor. We type in OW. Will it get the gist? Watch clips. 7 days ago? No. Give me the new one. Man, the new character's got a wall climb. Frogger is funny, man.
please, please. Let's go on. Let's go on. Ready? Yeah. Bro. Nah, how broken is Doom Fist? How broken is Doom Fist? Oh my god. Broken it? Nerf him, Wizard. What are we doing? Okay. This has gotta be reportable. Like, at least I'm still trying. I need help. Excuse me?
Break's almost over, man. And that's break.
Okay.
What's
Mantra was always supposed to be.
sweet? All right. Where were we? Yes. Okay, from here. Well, we listed some of the forces in the x direction, some of the forces in the y. Looks like they make a matrix of the whole thing. Well, x becomes y, so some of the forces in the y, some of the forces in the z, some of the forces in the x. Looks like we're gonna have. Oh boy, I hat, J hat, and K hat. They won't be the same. It's weird. I'm trying to do half of the problem normal, and then the other half is not normal. But my IJ and K hats really aren't IJ and K. They are Y, Z, and X. So this should still be the same. We have 3/7 TAB plus 2/6.5 TAC minus 6/9 TAD. Here in the Z, we have negative 6/7 TAB minus 6/6.5 TAC minus 6/9 TAD plus 700 newtons. And for X, negative 6/9. Whoa. it's just going to be a 2 over 7 TAB minus 1.5 over 6.5 TAC minus 3 over 9 TAD. Okay. Now, from here, we can make a matrix. Oh, actually, we don't know F. Sorry. TAB. This is just F. I think we're going to find F. Yeah. Okay. So we can actually solve for the TAB and all of these. So 3 over 7 times 700 is 300. And negative 6 over 7 times 700 is 600. And then we have 2 over 7 times 700, which I'm getting to be 200. Okay. With this, since they're on this side, we want them to be moved over to the other side. We're going to have a matrix of TAC, TAD, and F. F's, and this is going to be Y, Z, and X. This is going to be 0, 1, and 0. It could be 0 and negative 1, but I think it's 0, 1, 0. TAC for Y. Let me just get rid of these. Since we already solved for those, and those, in fact, are going into matrix B here as this is going to be negative 300. It shouldn't be negative 6 over 7, should it be? Yeah, it should be. Then this would be 600. This would be negative 200. Okay. And then here we're going to have 2 over 6.5. Negative 6 over 9. Here we have negative 6 over 6.5. Here we have negative 6 over 9. Here we have negative 1.5 over 6.5. And then here we have negative 3 over 9. Plugging these all into a matrix. Whoa, whoa, whoa. It's like a 3x1 matrix. Here we go. Negative 300, 600, negative 200. I have to do matrix. Matrix A to the inverse of matrix B. Oh, haha. Funny. Okay. Good. So I'm getting that TAC equals TAD equals, and the F equals should be 130 newtons, 510 newtons, and 1060 newtons. Which, those are the correct answers. And this one was really scary because I did this thing my way completely. There's no Chegg you'll find that does it quite like I do it. Oh, I hope that made sense. Hope that made sense. Okay. Is this the last one? Yeah, sure enough. So, again, oh boy, what a mess. We have points A, B, C, and D. This is the origin. At least X, Y, and Z are fine. So we're gonna have 3, 0, 1. B is gonna be 2, 3, -1. C is gonna be 0, 0, 1. D is going to be 0, 3, 3. Yeah, okay. Now, what are we supposed to find? AB and CF? Well, let's see. The moment, oh my gosh, a moment? What is the moment about line CD due to force F? F goes through AB, so we're going to want to find vector AB, which is going to be 2 take away 3, -1. 3 take away 0 is going to be 3. -1 take away 1 is going to be -2. And then we want magnitude of AB, which is going to be the square root of 1 squared plus 3 squared plus 1 squared. Oh gosh. What is even that? It looks like it's square root 11. I don't like it, but it's square root 11. Sure enough. Yeah, which makes sense. Turns out it makes a lot of sense. Why does this one say square root 14? The square root. And then if we do square root of 1 squared plus 3 squared plus 1 squared, it's not the same. Wait, negative 2? Oh, yes. Yes, it's square root 14. That's a 2, not a 1. I'm stupid. So we're good. Now lambda AB is going to be equal to negative 1 over I hat plus 3 j hat minus 2 k hat, and this is going to be square root 14. So now we've got lambda AB, we have force F. What is a moment? A moment is going to be R cross F. It looks like we also want this for CD. Vector CD is going to be equal to 0, negative 3, 1 take away 3, negative 2. Wait, CD should be the other way around. D take away C, so it should be 3, positive 2. Yeah, okay. And now the magnitude of CD, square root of 3 squared plus 2 squared. Is that going to be the square root of 13? Lambda CD is going to be equal to 0 I hat plus 3 j hat plus 2k hat square root 13 square root 13. Okay, with these, now we can finally, hopefully, potentially, this is what they call the scalar triple product, which I personally don't like. Which let's see, a moment is a distance across a force, right? And we have the distance in lambda, let's see, AB, and we have the force of F, so we have to do that. Let's see. We'd want to find the force. The force for FAB should be F AB lambda AB. So what we would just need to do is multiply lambda AB times force, so that would be equal to 1 square root 14 I hat plus 3 square root 14 j hat minus 2 square root 14 k hat times 150. Simple as that. So for the scalar triple product, this would turn into, just set this up, it's going to be very large. This would be 0 3, whoa, why am I writing it up there? 3 square root 13, 2 square root 13, and then right down here it would be, let's see, distance, this would be R AC, which this would be equal to we already have AC? We don't have AC. So that would be, really should be CA, shouldn't it? The distance here would be 3, 0, 0. This would be 3, 0, 0, and then here we would have 150 square root 14 plus, let's see, what's 150 times 3? 450 square root 14 minus 300 square root 14. Which this is going to be, oh my gosh, a triple product. I'll just write down how this is dictated then. So that would be a negative 3 square root 13. Okay. And this would be times negative 300 times 3 over square root 14 plus 2 square root 13 times 450 times 3, I should say dot 3 square root 14, which is equal to 2700 square root 182 plus 2700 square root 182, which is going to be equal to 400 .2746, which is going to be moment CD is going to be equal to 400 Newton meters. Yeah. And that's it. That's all of the statics exam 1. I think I got everything but the last question the first time I did this, so that was very good. Or maybe I got a little points off on everything. I think I ended up with about an 80 or something. But it's good to review this. We don't quite have exam 2 yet. I would love to review that, but yeah, I guess statics exam 1 done in just over an hour. Nothing left. Scroll back through this again, make sure I didn't forget anything. Nope. Even got the bonus question. Okay, sweet. Yeah, there you guys go.